All right, when you're ready, go ahead and find the 25-26 notes. And we are going to look at the power rule, the constant, sum, difference, and constant multiple rules for finding derivatives. So we're going to do some crunching of derivatives. So you'll see in the top left box, the constant rule. The derivative of a constant is 0 because y equals a number is a horizontal line, and the derivative of a horizontal line is 0. All right, everybody got the yellow sheet now? We're good? Okay. Wrong one. There we go. Okay. The power rule. Now, what's really, really important, you must be in the form f of x equals x to the n power. This does not apply if I have a product with variables in both factors. This does not apply if I have a quotient with variables in both the numerator and the denominator. So we will next week learn the product rule and the quotient rule, but we're not quite ready for that. All right, so in example 1, it says find the derivative of each. So letter A, easy peasy. Bring down the power, decrease the power by 1. In letter B, I'm not in the correct form. So what I can do is I need to remember my algebra 2 rational exponents. The fourth root of x cubed is x to the 3/4 power. Now you're going to bring down the power, decrease the power by 1. There is nothing wrong with leaving your answer as 3/4 x to the negative 1/4. Or I could drop it down, or so there are 3 acceptable answers. All right, try letter C. Put it in power form, x to a power, then find the derivative. Make sure, okay, I want us to work on proper notation. When you find a derivative, put g prime, f prime, y prime. Make sure you're indicating that because there's a difference between y and y prime. So let's remember our negative exponent rules. I'm going to first rewrite this as y equals x to the negative 3rd power. Bring down the power. Now when you decrease by 1, what does that become? Negative 2 or negative 4? Negative 4. That is an acceptable answer. Or you can rewrite it. You do need to be comfortable with both representations because on a multiple choice question, if you stopped at negative 3x to the negative 4, but that's not an answer choice, you need to recognize that that's negative 3 over x to the 4th. All right, the constant multiple rule. If you have a constant times a function, it is the same thing as the constant times the derivative of the function. Now, I don't technically separate it. I just know that it's hanging out there. So I'm going to bring the power down, and that's 14x to the 6th. In letter B, this one is not in power form. So your first step should be to rewrite it in power form, x to a power. Now I can find the derivative. So I'm going to bring down the power, decrease the power by 1. And if I simplify that, that's negative 6 over x cubed. Letter C. This is not in the form I like. So I'm going to rewrite this. And notice that I'm writing f of x. So let's try to be really clear in our notation use. So I'm going to rewrite this as f of x equals 1/8 times x to the 5/6 power. I'm going to pause a moment, let you bring down the power, decrease that power by 1. And if it helps, maybe do this. Like maybe if it's too much mental work for you, you can do this. You can literally write the power in front and do 5/6 times 1/8, because sometimes you're going to have some fraction reducing to do. So that is what, 5 over 48. Oh, and let's put that x to the 1/6. Now, kind of a convention in math is, do you see that the original function f of x was a 6th root? It had a radical. Then typically what you'll find in an answer is a radical. It's not wrong to leave it here, but that's just usually how you'll see an answer. Not always. All right, I'm going to pause a moment, and I want you to try example 3. Be careful, be careful, be careful. Remember, these have to be in power form before you can find the derivative. Now, when I say power form, it is x to a power, not a 3x to a power. It has to be an x to a power. So a few of these you have to rewrite. All right, discuss at your tables. I know a few of you might still be on letter D, and that's okay, but let's discuss. What did you get for each part?
The second one is different. You also get 300. So the first step is 1/8. So the first step is 1/8. So is it 1/8 times the x to the 4? I got that. It's just divided by 8. Okay, yeah. Yeah, okay. So then, you 3 to the 4. Is that what you do?
Yeah, 3 to the 4.
Yes, that's what I would give hold on. So it doesn't make minus 1/8. 1/8 times. What was that? 3 times.
All right, I'm going to go ahead and start this one. If I bring down the power, that's 12x cubed over 8, which does reduce to 3/2 x cubed. In letter B, I cannot do the power rule as it is written. I have to simplify this as 81 x to the 4th over 8. Now, when I bring down that power, it might be a little bit easier to just leave it like that, and you get 81 over 2x cubed, 81x cubed over 2, however you want to write that is fine. So again, the power rule does not apply to this original function because that's a 3x. It has to be x alone. So that's a distinction there. In letter C, I need to rewrite this one. It's not in power rule form. It has to be x to a power. X to a power. So now I can bring down the power. You can leave it like that or have negative 18 over 7x cubed. All right, letter D. I cannot do the power rule yet. I'm going to first multiply 7x squared. I'm still not ready for it. Now I can bring down my power. I got negative 18 over 49 x to the negative 3rd, or negative 18 over 49 x cubed. All right, give me thumbs up. How are we feeling? Up, out, or down? Okay, all right, pretty good. All right, here is the sum and difference rules. If two functions are differentiable, that means you can find their derivative, then the sum of those two functions is just f prime of x plus g prime of x. Likewise with the difference. So let's look at example 4, letter A. This one, we only know the power rule, okay? We only know the power rule. We will eventually figure out how to do these another way. But for now, what I can do is I could split this into a difference in sum all over x. That's true, right? This is all, those terms are being divided by x. So that's x squared minus 4 plus 5x to the negative 1. Now I can find the derivative. No. Okay, great question. So look, the only derivative rule that I know right now is called the power rule. So it's x to a power, you bring the power down. I don't have x to a power. But what I can do is, this is a fraction, right?
Yeah.
Everything in the numerator is being divided by x. So what I decided to do is to manipulate this, simplify it perhaps, and take x cubed over x minus 4x over x plus 5 over x. That's all I'm doing.
Yeah.
Okay, so then once I get here, then I can apply the power rule. And I'm using the sum and difference rule.
Yeah.
Okay, does that make sense now?
Yeah.
Okay. All right, so here we go. This will be 2x. What is the derivative of 4? 0, okay? The derivative of a constant is 0. Let's write a note. The derivative of a constant is 0. And that's actually going to be one of the hardest things to remember. Students will go, wait, what happened to that 4? What happened to that 4? I'm always asked that. All right, then I'm going to bring down the power, decrease the power by 1. You can leave it like that or rewrite it as 2x minus 5 over x squared. Now, I'm also going to rock your world. And what about this? What if I tell you I can also write it as 2x cubed minus 5 over x squared? Where does this come from? Yeah.
From putting it into the x over 3 or x over 2 times.
Yeah, building a common denominator, right? Yeah. So multiplying this one by x squared over x squared builds the common denominator. I just want you to see that this is what's going to happen to you. Is you might get this as a multiple choice. You did this, but the answer's here. Okay, so you do just need to be comfortable. All right, if I only know the power rule, what could I do to g of x in part B so that it's in power rule form? Distribute, or use FOIL using the distributive property. So let's do that. So that gives me x cubed minus 3x squared plus x minus 3. Oh, isn't that nice? Then I can do the power rule here. So I get 3x squared minus 6x plus 1. Don't forget the derivative of a constant is 0. So that's where the minus 3 went. All right, for letter C, Pascal's triangle is awfully convenient here. This would be 1 times x cubed. Now I'm going to show you how I do this and whether your pre-calc teacher did this or not. Instead of memorizing that it alternates, I just always do it like this, and then I take care of any sign issues that I have. So I can use Pascal's triangle rather quickly. Now, a cube isn't terrible if you did x minus 3 times x minus 3 times x minus 3. The good news, next week we're going to learn another method here so that we don't have to do this process. So that's what? X cubed minus 9x squared plus what? 27x minus 27. All right, then the derivative is pretty straightforward here. 3x squared minus 18x plus 27. All right, in letter D, sorry, g of x, How about this? If the square root of x is x to the 1/2, can you handle this if I do two things here? Okay, the square root of x. So if you have a quotient at this point, there's going to be a single term down here. We can't do it with sum and differences in the denominator. That's what our quotient rule will be that we learn next week. But a square root of x is x to the 1/2. I'm still not ready for my power rule. How can I simplify 2x squared over x to the 1/2? Use our basic algebra 1 exponent rules. You subtract the exponent. So I'm going to pause a moment, let you still simplify g of x to make it in the power rule form, and then find the derivative. Okay, so subtract your exponents. All right, initially, x squared over x to the 1/2, that's 4/2 minus 1/2 is 3/2. This is 1 minus 1/2 is 1/2. Now I can do my derivative. And if it helps, especially with the fractions, I mean, you can do an extra step, or if you can do it mentally, terrific. So do you see here that the 2's cancel and I get 3x to the 1/2 minus 3/2 x to the negative 1/2. Okay, now let's practice how you would get a common denominator here. Well, the common denominator is 2x to the 1/2, correct? Or if it helps, maybe this would help. Let me do this over here. Let's rewrite it like this. So my common denominator is, yeah.
Wait, so on the second half of that, wouldn't the negative 1/2 become negative 3/2? Between it was 1/2. It was 1/2. Oh, okay, yeah. Sorry.
That's okay. Yeah. Okay. So now, if my common denominator is 2 square root x, I can multiply the first term by that, and that'll give me what? 6x minus 3 over 2 square root x. I just want you to be comfortable with full simplification. If this is multiple choice, I want you to see how they're going from here to there. Building common denominators. All right, questions on the power rule. Remember, the derivative of a constant is 0. In order to use the power rule, you have to have x to a power alone. So sometimes you have to do some algebra manipulation to get it to x to a power. Okay? All right, so now what's really nice is that we're going to keep doing equations of tangent lines over and over and over again. You will be really good at them by the time May rolls around. So let's look at example 5. It says, write the equation of the tangent line to the function at the given point. Well, What are the two things you need in order to write an equation of a line? Point and the slope. Well, they gave us the point. Yay! How do we find the slope? Find the derivative. The derivative is the slope of the tangent line at that point. So this will be 1 minus 4x, and the x value is 1. So we're going to use point slope. And our point was 1, negative 1. So that'll be y plus 1 equals negative 3 times x minus 1. You are always welcome to leave it in point slope form. So there's a caution here to the right. A very common mistake in an example like 5a is to think the slope of the specific tangent line is 1 minus 4x. It is important that you find the specific slope to that point, 1, negative 1. All right, I'm going to pause and I want you to try letter B. Write the equation of the tangent line to the function f of x equals 2 square root x at x equals 1. All right, on this one, I rewrote f of x as 2x to the 1/2. When you bring down the 1/2, 2 times a half is 1, so they cancel. So I get x to the negative 1/2 power. Plug in x is 1, and my slope is 1. Now my problem is I only have the x coordinate. How do I find the y coordinate of my point? Plug it into f of x, and you get, what, 2? All right, so this is y minus 2 equals 1 times the quantity, x minus 1. If you like to put it in y equals mx plus b, that one was nice and easy to do. All right, give me thumbs up. How are we with equations of a tangent line? We're getting it? Okay. All right, example 6. Finding locations of horizontal tangent lines. At what point or points does the graph of y have a horizontal tangent line? Well, what do you know about a horizontal tangent line? Slope is 0, right? The slope is 0. Well, slope is the derivative of the tangent line at that point. So this means my derivative is 0. Oh, okay. So let's find the derivative. Set it equal to 0. And then we can find the x coordinate. Now, it didn't say at what x value. And so in AP Calculus, one of the skills we are working on all year is reading problems carefully. Sometimes it'll say at what x value, and then I would be done. But it says at what point or points. So what do I need to do to find my y coordinate? Yeah, plug it into my y equals. So the point is -2, -5. So, you know what would be cool is, let's go to Desmos. Let me pull up my Desmos real quick and show you this. This is y equals x squared plus 4x minus 1. And, ooh, isn't that cool? It is at x equals -2, -5. You see that? That's really cool. And it's at the vertex, right? That's a parabola. That makes sense. All right. Example 7. Ensuring tangency to a given line. It says you're given the function f of x equals x cubed plus kx. And the line y equals 6x minus 2. Find the value of k so that that line is tangent to the function. So let's stop and think here a minute. I don't know exactly where this is, but I know an x cubed has this general shape. Here's what a tangent to an x cubed could look like. So what are some things we know? What do we know here? What could help us? Logan?
The slope is 6.
Ah, nice. Okay, the slope is 6 of our line. And then what does that tell us? The derivative, which would be 3x squared plus k, has to be equal to 6. So k is 6 minus 3x squared. All right, what else do we know? Okay, I'm somewhere, but not exactly where I need. Yeah, Dylan?
X is -2.
How do you know that?
Because of, if you put, if that equals
Yeah, that's not point slope. What else do we know? Look at the drawing. Look at the drawing. Like I'm trying to give you a gigantic hint here. Here's the curve. Here's the point. Here's the line. Yes, okay. Bingo, bingo. There we go. So what I know is they are going to have a point of intersection at the tangent point, okay? So let's maybe write ourselves a note, because it's going to be one of those things that is inferred, okay? F of x and the line have a point in common, and it's at the point of tangency. Oh, all right. Anybody now see what we can do? That's definitely an option. Yeah.
substitute k.
Yeah. Yeah. Now, Michael, you really could have solved it for k and then set the 2 equal. It's going to do the same job. It will do the same job. All right, so what is that? X cubed plus 6x minus 3x cubed equals 6x minus 2. Negative 2x cubed. Oh, the 6x's cancel. Oh, this worked out beautifully. So I got the x coordinate, but let's reread the problem. It said it didn't ask me for x. It asked us for k, didn't it? But I can find k now that I know x. All right, that was a super cool problem. That was a really, really nice problem. Okay, so your homework you are going to submit is a circuit